Have you ever wondered how this type of complex piping projects are performed? Use of standard available pipe fittings are not always possible. Sometimes you have to cut the pipe at angle, also called miter joint. Obviously, mathematical and trigonometric relations can be used for calculations, but today in the age of AI it is very difficult, inefficient and not very precise. Fortunately, we have CAD softwares like AutoCAD SolidWorks that can help us in these kind of project. So by the end of this very short video you will be able to perform these kind of jobs like professionals in very easy and precise way. So let's begin. Let's say you have a pipe of nominal size 10 inches. And you want to cut that pipe at some arbitrary angle, let's say 30 degrees. Let's look at this pipe from the front side to see the cut at an angle clearly. If we make the right cut part disappear, we can see the cross section of cut surface. Why we want to cut in this way? Because we want to route the pipe at an angle. As you can see here, the pipe cut length at the right side is at some angle to the pipe cut length at the left side. Let's look at from the front view to visualize it more clearly. To cut the pipe in this way at some specific angle, we first have to make some marking on the pipe surface, to guide the path to be followed during cutting. Marking the pipe for cutting at right angle is a circle and easy to make. However, mark for cutting at an angle is an ellipse and needs a lot of mathematical and trigonometric calculation. But we can use SolidWorks or any other CAD software to make these calculations very easy and precise. Suppose we have a pipe piece at workshop. First, we have to make a mark at right angle to the longitudinal or lengthwise direction of pipe, which is obviously a circle. Then we have to divide this circle into some equal segments. The more the segments, more precise will be our cutting mark. Here we are dividing our circle into 8 equal segments. Then we will have to make some straight lines on the surface of the pipe. The length of these lines are to be calculated so that when we join end points of these lines, we will get our cutting mark. These lines are of different lengths. Let's take a look at them from the front plane. The line at the top is longer than the lines beneath. Now let's join the other end points of these lines to get the cutting ellipse. To calculate the lengths of these lines, we start with a piece of 10-inch pipe whose outer diameter is 273.05 mm. We select front plane to create a sketch. We first use convert entity command to convert bottom right and top side of pipe into a line. Then we sketch a center line vertically from bottom to top of the pipe. After that we sketch a line at an angle as shown here. We make this angle 30 degrees. We arbitrarily chose 300 mm distance of this line to one end of pipe. Finally we trim our sketch and then exit this sketch. Take a look at the sketch. It will cut the pipe at angle of 30 degrees at distance of 300 mm from the left extreme end of pipe. We use cut extrude command to cut according to the sketch we have just created. Now we have piece of pipe that is straight at right angle at one end and at 30 degree at the other end. The minimum distance between these ends is 300 mm. Finally, let's start our desired calculations. First, we start with a 3D sketch. Then we use convert entity command to convert the outer circle of straight pipe end as shown. Then we divide this circle into 8 equal parts with the help of lines. More the division of this circle, more precise will be our calculations and cutting mark. Again we use convert entity to get the outer ellipse of pipe angled cut surface. Now we can hide this pipe piece to see the things more clearly. Now select the line command. Start a line from the topmost point of circle. Make sure this line is aligned along z-axis because our pipe surface is also aligned along this z-axis. Terminate the line at the ellipse. Revolve this sketch to visualize and to make sure everything is okay. Now access the evaluate command and measure the length of these lines. The topmost line is 457.65 mm. The bottommost line should be obviously 300 mm. However, the lengths of lines in between should be within these two values.